You know that feeling when you're driving on a brutally hot day, totally enjoying that blast of cold air from the vents, and then suddenly, the air turns lukewarm, your AC just seemingly gives up? It's incredibly frustrating, right? Well, what if I told you that this sudden cutoff isn't actually a flaw, but a highly sophisticated survival mechanism? Welcome to this explainer. Today, we're going to completely demystify why car ACs trip. We'll look at why this mechanism, which is so often misunderstood as a huge headache, is actually a vital safeguard keeping your car out of the repair shop. So, here's our game plan for today's explainer. First, why car ACs absolutely must trip. Second, we'll meet the 3 guards. And third, troubleshooting tripping problems. All right, section 1, why car ACs must trip. We're going to start by neutralizing a huge misconception right off the bat and looking at why a nonstop AC is actually a total recipe for disaster. Picture this. You're on a massive road trip. You've got the AC continuously engaged. Under the hood, an electrical signal has created a magnetic field, locking the AC clutch and forcing the compressor to just relentlessly push refrigerant through the system. Without a break, the internal pistons of that compressor will start to severely overheat. This constant friction and heat permanently damages the internal seals, which drastically reduces the lifespan of your compressor. So while you're chilling in the cabin, your compressor is quite literally burning itself alive. But it actually gets much worse than just overheating. It's literally a cascading failure. Look at step 1. The compressor runs continuously, driving the temperature way down. Step 2. The cooling coil inside your dashboard hits freezing. Step 3. Ice literally forms on the coil. And this ice acts like a concrete wall, choking the system and completely stopping the circulation of the refrigerant gas. All of that immense, fatal pressure is shoved right back onto the compressor, completely destroying it. So, the absolutely crucial point here is 0 degrees Celsius. This is the ultimate danger zone. This is exactly where moisture in the air turns to ice on your cooling coil. The entire auto-trip function of your car's AC is designed specifically to prevent the system from ever hitting this freezing threshold. Which brings us to section 2, the 3 guards. Now, let's meet the specific sensors that monitor the system and tell the engine control module, the brain of the car, exactly when to pull the plug. These 3 guards are the engine coolant temperature sensor, the high pressure switch, and the thermostat sensor. They constantly send real-time data to the ECM to trigger the auto-trip function way before any catastrophic damage actually occurs. First up is the ECT sensor. Now, what's fascinating about this sensor is that it prioritizes the car's overall survival above your personal comfort. If the engine starts heating up, let's say you're climbing a steep hill on a scorching day, the ECT sensor catches this. To save the engine from totally destroying itself, the ECM will ruthlessly sacrifice your AC. It trips it off to immediately drop the mechanical load on the engine. You might sweat a little bit, but hey, your car lives to drive another day. Next is the high pressure switch, sitting right there on the high pressure line. This guard is looking out for 2 extremes. First, if the system runs completely dry, it won't even let the compressor turn on. Conversely, if the pressure spikes dangerously high, which happens a lot if your condenser grill is choked up with bugs and dirt, this switch instantly trips the AC to prevent a massive system blowout. Guard number 3 is the thermostat, or evaporator sensor. This is your direct line of defense for the cooling coil itself. It keeps a microscopic eye on the exact temperature to stop it from reaching that 0-degree freezing point we talked about earlier. This leads to a beautiful, highly calibrated dance. The ECM shuts the compressor off right before freezing, usually when the coil hits 1 or 2 degrees Celsius. The AC trips, the system takes a breath, and the coil safely warms up. Then, as soon as it hits 3 degrees, boom, the ECM kicks the compressor back on. This safe operational cycle between 1 and 3 degrees is exactly what a healthy, properly tripping AC looks like. Moving right into section 3, troubleshooting tripping problems. We know how it should work, so let's check out our diagnostic rogues gallery and figure out how to identify which guard is acting up when things go wrong. Mapping out these symptoms is honestly the fastest way to troubleshoot. For example, if the thermostat sensor is damaged, the AC might rapid cycle or just refuse to trip entirely. But look at this second one. This is wild. If your AC never trips, you might actually have hot air leaking in from the heater coil compartment. Because hot air is leaking in, the cooling coil literally never manages to drop to 3 degrees, so the compressor runs endlessly trying to catch up. On the flip side, if your AC trips repeatedly and rapidly, you're usually looking at a choked AC filter Or, incredibly, a weak fan motor where the internal carbons, the little brushes conducting electricity, have just worn down. Now, if you suspect the high-pressure switch is the culprit behind repeated tripping, please do not just blindly pump more gas into the system. Always start by hooking up a diagnostic scanner to check for sensor codes first. If the code points to the pressure sensor, fix that before assuming you just need more Freon, because overfilling a system with gas will actually cause it to trip even more. Here's a really fantastic diagnostic trick from our sources. If you have a 2-wire or a 4-wire high-pressure switch, you can temporarily short the wires together to bypass it and see if the AC kicks on. It's a great, quick test. But a quick warning for sure, if you have a 3-wire switch, you absolutely cannot bypass it this way. That requires proper digital diagnostics. Finally, what if the ECT sensor is sending false overheat signals? Sometimes a failing sensor tells the brain the engine is boiling, causing your AC to trip when the engine is perfectly cool. You can verify this by comparing the digital scanner reading with the physical temperature of the radiator hose. Just use your hand or a temp meter. If the scanner says emergency but the hose is cool to the touch, you've found your fake emergency. So, we've covered a ton of ground in this explainer, from the physical danger of freezing coils to the logic of the 3 guards. The next time you're driving and your AC suddenly cuts out, ask yourself, is the system just saving its own life, or is it time to check the sensors? Which of the 3 guards is trying to tell you something?